So from what I saw in that pre-assessment, we seem to have a decent idea of multiplying fractions. Some of you forgot the dividing fractions part, but it's connected to multiplication. And there's also a certain thing that we can do when we multiply fractions that I think I noticed one of you did. Okay, but how do you multiply fractions? What's the basic rule, Zara?
Times the numerator by the numerator and the denominator by the denominator.
Right. So for example, in this one, we would just simply multiply 7 by 1 over 9 by 4, and that's our answer. And this one, it happens that you can't reduce it. These are the lessons, not the exercises. Now, I don't know what you guys were taught when you were taught multiplying fractions. Whether you were taught just to multiply the numerators, multiply the denominators, and reduce at the end. You can actually reduce before you multiply. What that means is you can pick any numerator with any denominator, pick a pair. They don't have to be diagonal, they could be vertical, okay? And reduce them before we multiply. So look at the numerators and denominators here. Can you pick a pair, one numerator, one denominator, that you could reduce? Heather? 3 and 9. So I could divide 3 and 9 by 3 and get 1 and 3. Is there another pair that you could reduce? Well, there's only one pair left, yeah. 4 and 8. What did I divide 4 and 8 by to reduce that?
2 or
4. So 8 divided 4 is 2. 4 divided 4 is 1. So now I'm left with 2 times 1 over 3 times 1. Reduce everything correctly before you multiply. You'll never have to reduce at the end. Okay? Yes. That. Okay? Go ahead. Let's hear it.
I found in English
Oh, diagonal?
yeah.
Diagonal.
No. Yes, it is.
Okay, like this. Like this.
Yes, and I
Okay, you know what? Here, even better. Thank you. Yes. Okay, keep going. What do you mean? Go, finish it.
It's a different.
Yes. Okay, so you just go 8 times 3. Okay, so this is 24. And on the bottom is 36. So now you have to reduce it,
Oh.
right? Okay, so yes, that is one way to do it. You can multiply them like this and then reduce after, and you'll get this. But you can reduce first and always get the reduced answer. Okay? Yeah, no, I get what you mean. Thank you. The reason now, you can still do it this way. It'll work. But I would really like you guys to get into this habit, because when we start doing algebra and we start throwing fractions in, we're going to be doing this kind of stuff. So if you're used to it now, it'll make it when we get to it later on in the year that much easier. Okay. The next one. What happens when we have a whole number by a fraction? What do we do? Okay,
You put a 1 under the whole number?
negative 5. So 5 over 1 times 7 over 15. And now see if you can get back into that habit. Can I reduce a pair? 5 and 15, right? What could I divide each by?
5.
And what do I end up with after I divide? And now it's 1 times 7 over 1 times 3. And since we've reduced everything correctly, we don't have to worry about reducing the final answer. So your final answer is 7 over 3. You've got 2 improper fractions. Okay, and remember, you don't, if your answer is an improper fraction, you don't have to change it to a mixed number. You can leave it as an improper fraction. Is there a pair I can reduce? No. So all I can do is 11 times 11 over 5 times 3. 11 times 11?
111.
Almost. 121. Over 50. Okay, fire keeps putting those segments. Division. We don't technically divide fractions. We change them to a multiplication question. So when we divide 2 fractions, it's the same as taking the first fraction times what we call the reciprocal of the second. How do you find a reciprocal of a fraction? You just flip the numerator and denominator. And now it just becomes a multiplication question. Look for reducing. Is there a pair? 5 and 10 can reduce down to 1 and 2. So I am left with 1 times 11, which is 11, over 8 times 2, which is 16. And since I reduced everything before, I don't have to worry about reducing after. Why does that work? Why can we do that? Were you guys actually explained why? Or were you just told, flip the second fraction and change it to multiplication? Here's why we do it. I'm going to write the division in a different way. This means the same thing. I just used a different division sign. Okay. So what I want to do is I want to make the denominator 1. Because if I make this on the bottom 1, then my answer over 1 is just my answer. What can I multiply 10 over 11 by so the answer would be 1? Wouldn't it be 11 over 10? Because I can reduce these to 1 and 1. I can reduce these to 1 and 1. And whatever I do to the bottom of a fraction, I have to do the exact same thing to the top. Okay? You have to do the exact same thing because this is like multiplying it by 1. And remember how we do equivalent fractions. When you find an equivalent fraction, you multiply the denominator by something, you got to multiply the numerator by the same thing. So notice her answer is going to be this over 1, which is just this. That's why we multiply by the reciprocal. If you look at division in a different way, okay? I don't like just saying, do it this way. If you have an idea of why you're doing it that way, I think it helps you understand it better. What would you do with this one? What's the first thing you do?
Put the 4 over.
Put the 4 over 1. What's the next thing you would do?
And choose the divide and what's in it.
Change the question to a multiplication question. Yes. And what's the next thing you would do?
Do the math.
Do the math? What does that mean?
Like, do the numerators and then do the denominators. Yeah.
You want to check for something first? Check if you can reduce first, can you? No, you can't do this one. So now you do the math. Multiply the top and the bottom and get 24 over 5. Remember, you don't have to change it to a mixed number. This one. What would you do first? Yeah.
A multiplication.
Then, right, if you can. Is there a pair that you can reduce?
22 and 4.
You can divide each of these by, get 11. Good. And then 11 times 3 is 33 over 7 times 2, which is 14. And that answer is reduced. Finally, let's look at a couple of word problems. And basically you have to decide, okay, am I going to multiply it to find the answer here, or am I going to divide? And then eventually, when you get a fraction word problem, you're going to have to figure out, okay, do I add, subtract, multiply, or divide? It's going to be one of the 4. So Olivia took out some glasses and juice from the pitcher. The capacity of each glass is 3/10 of a liter. If there was enough juice for 6 glasses, how much juice was there? Multiplication or division? Multiplication, because if each glass contains this much juice, 3/10 of a liter, then 6 of them must be 3/10 times 6. But instead of 6, I'm going to put 6 over 1. Because I need 2 fractions to multiply. Next. What would you do next?
You reduce
Excellent. For what?
to 3 and 5.
Good. And you get 9/5, and you need units here of a liter. So basically almost 2 liters, or 1 4/5. But again, you don't have to change it. You can leave it as a fraction. Okay. And the last example. A baker is making croissants. She has 18 pounds of dough, and each croissant is made from 1/8 of a pound. How many croissants can she make? So she's got 18 pounds. She's got a lot of pounds. And each one of them is 1/8. Dividing, how am I gonna divide?
Once by 1/8.
Right.
Because I need to figure out how many eighths are in 18 pounds. And that will tell me how many croissants I can make. So we switch it to a multiplication question. And we get 18 times 8, which gives us 144 over 1, or we don't write them over 1. She can make quite a few. And that kind of makes sense if you think about it, because if each one is 1/8 of a pound, then 8 of them would be a whole pound. But I've got 18 pounds, so it's 8 times 18. So really, that's what we did.